Hi everyone, it's Scott from Maths Logos. In this lesson, we're going to look at problem solving involving some decimals. Because it's a problem solving type lesson, I'm going to let you pause the video and give this question a go before we go through it. Okay, so hopefully you've had a chance to run through this one. Let's have a look. Sam and Jim are driving from London, so that's in the south of England, to St Andrews, which is in Scotland, a distance of 715 kilometers. At the start of the journey, Sam's fuel tank contains 58.75 litres of petrol, and Sam's car uses an average of 0.07 litres of petrol for every kilometre travelled. Jim claims that they can complete the journey without refueling. Is Jim correct? So the first thing that we can do is work out how much fuel they used on the journey. We know that they used 0.07 litres for every 1 kilometre, and we know how many kilometres they travelled. So I can say the total fuel is equal to 0.07 litres every kilometre. That's how much they would use if they just travelled 1 kilometre, 0.07 litres. But they travel 717 kilometres. So I would multiply these two numbers together. That's going to give me the total fuel. Now, throughout this lesson, there's going to be some questions that are non-calculator and some that are calculator. This particular question is non-calculator. So I need to do 0.07 multiplied by 715 without a calculator. Now there are a few ways to do this. I'm going to use the related calculation 7 times 715, and then I'm going to scale that calculation down later on to the one that we want to work out. That's where we're aiming with this. Let's go ahead and do the 7 times 715. So again, bit of rough working out, 715 multiplied by 7. 7 multiplied by 5 is 35, carry over your 3. 1 multiplied by 7 is 7, add on your 3 is 10, carry over your 1. 7 multiplied by 7 is 49, add on your 1 is 50. So that's your answer, 5005. Okay, so that's the answer to this calculation, 5005. But I want to work out 0.07 times 715. And what I want to do is I want to see how did I go from 7 to 0.07? Well, the answer is I divided by 100, which means my answer to this calculation that I'm interested in is going to be 100 times smaller than the answer we just worked out. That gives us an answer of 50.05. And come back over to here. Now I know the answer. The total fuel used was equal to 50.05 litres. With these types of questions, we want to make sure we've actually answered it. We're trying to decide whether the claim that they can complete the journey without refueling is true or not. And if we have a look, they had 58.75 litres in the tank, and it'll only take them 50.05 litres to do the journey. Therefore, they can do it without refueling. They wouldn't have a whole lot left over, but they could. Let's write that mathematically. I can say that 58.75 litres is greater than 50.05 litres. That's the amount they need to do the journey. Therefore, they can complete the journey without refueling. Okay, so I put in that sentence conclusion. It's always good to put in a worded conclusion in these types of questions. All right, here's another one for you to do, just to draw your attention to the fact that this is a calculator question. So go ahead and give this a go, and then we can run through the solution in a second. Okay, let's go through it. Table 1 shows the average amount of electricity in kilowatt hours used by 4 different household appliances per hour. Table 2 shows the cost of electricity per kilowatt hour for 2 different energy providers. Mr. Davies is currently with Alpha Energy. He uses clothes dryer for 1.5 hours and his oven for 1 hour and 48 minutes. Mr. Davies claims that if he switched to beta power, he would save more than 70p on the total cost of running these 2 appliances. Is Mr. Davies correct? What we want to start by doing is working out how much energy is used by the clothes dryer and also by the oven. So let's look at those in turn. I'm going to say the energy used. Again, just using words just to help structure my working out. And then we're going to look at the clothes dryer. So I'll say the dryer. And we'll work out how much energy he used for that. Well, he uses it for 1.5 hours. And if we go ahead and look at our table, go down to the clothes dryer, it uses 3.2 kilowatts every hour. So I need to multiply the 1.5 hours by the 3.2 kilowatts that it uses every hour. We have our calculator for this lesson, so I'll go ahead and type that in. 1.5 multiplied by 3.2 and turn that into decimal gives me an answer of 4.8. And my units are kilowatt hours. The other household appliance that he uses is the oven. So I'll write down the oven. And he uses that for 1 hour and 48 minutes. Now that's not a decimal hour as it currently stands. So we want to turn 1 hour and 48 minutes into a decimal hour. And thankfully for us, our calculator can do that. So if we go ahead and type 1, and then on my calculator, I hit shift and then the plus button, and it gives me this little symbol here. My calculator interprets that as 1 hour. Then I type in 48 and again hit shift plus, and my calculator reads that as 1 hour and 48 minutes. If I hit the execute button, it shows up like this, 1 hour, 48 minutes, and no seconds. And if I click format, I can then go down to decimal and turn that into a decimal hour. So 1 hour and 48 minutes is 1.8 hours. So that's how long he uses the oven for. And the oven, it uses 2.4 kilowatts per hour. So I need to multiply that by 2.4 kilowatts. Technically, it should be per hour like that. I didn't do that in the previous one. I'll then do that calculation, 1.8 multiplied by 2.4. And that gives me an answer of 4.32 kilowatts per every hour. Okay, so that's how much energy he uses between the dryer and the oven. Let's work out the total energy he uses. So I'll say the total energy used. And that's equal to the sum of these two numbers. So 4.8 add my 4.32. And again, use my calculator. So I've already got 4.32 in my calculator, so I can actually store that as my answer. I don't have to even do anything to do that. I just hit the plus button. And if you notice, my answer is now the 4.32. I can add on the 4.8, hit execute, and that turns it into this decimal, which is 9.12 kilowatt hours. Okay, so that's how much energy he uses to run these appliances. Let's take that and use it in the next part of the question. Mr. Davies claims that if he switched to beta power, he would save more than 70p on the cost compared to what he's doing now, which is using alpha energy. So there's different ways we could do this. To keep it simple, I'm going to work out the energy cost for alpha. That would be how much energy he uses multiplied by the cost of energy. So go down to table 2. It's 0.29 and the units are important. That's in pounds. So it's 0.29 pounds or 29 pence per kilowatt. And I like to include the units in the question because it keeps me right. I'll then do that calculation. So 9.12 multiplied by 0.29. And that gives me an answer of 2.6448. And I have to be careful, that is in pounds. So I will write that in, 2.6448. And then I'll look at the cost for beta. Well, he uses the same amount of energy, and the cost for that is only 21 pence or 0.21 pounds per kilowatt of energy. Type in my 9.21 multiplied by 0.21, and that gives me an answer of 1.9152. We can see that beta power is actually cheaper, but is it 70p cheaper? That's what we want to work out. Well, we need to do the difference between these two numbers. So take that number and then take away the cost if I use beta power. And this is going to give me an answer in pounds, so I have to be careful with that. I'm going to store this as my answer, so I'm going to click the answer button. That has stored the 1.9152 as my answer, and I need to do 2.6448, subtract that answer, and that gives me an answer of 0.7296. And of course, that's in pounds. To turn that into pence, I multiply by 100, which is 72.96 pence. That's the difference between them. In other words, beta power is 72 pence and, well, pretty much 73 pence cheaper. So let's answer the question. Is Mr. Davies correct that beta power would be 70p cheaper? Yes, he is correct. So I said, yes, beta power is approximately 73 pence cheaper. Okay, here's our next example. It's my turn, so I'm going to do this question first, and then I'm going to give you one to do that's similar to it. It's also a calculator question. The triangle and the rectangle have the same area. Find the perimeter of the rectangle. Okay, so I know the area of these two shapes is the same. I can't currently work out the actual value for the area of the rectangle because I don't know what the width is. but I can work out the area of my triangle because I know the height and I know the base. I need to know the formula for the area of a triangle. The area of a triangle is equal to a half times the base times the height. Okay, sometimes we might see that as the base multiplied by the height divided by 2, but I like this one. Let's plug in our values. So we have a base of 1.92 centimeters and a height of 5 centimeters. And I'll plug that into my calculator and see what I get. So use the fraction button right there to get my half, or I could write 0.5 multiplied by 1.92 multiplied by 5. And that gives me an answer of 4.8 centimeters squared because it's area. Okay, so that's the area of the triangle. The triangle and the rectangle have the same area. In other words, this has an area of 4.8 centimeters squared as well. The area of the rectangle is the length multiplied by the width. I can say the area is 2.4 multiplied by x. I don't need to write in my multiplication symbol. It's just simply 2.4x. And I already know what the area is. It's 4.8. So 4.8 is equal to 2.4x. This is a one-step equation that I can solve. I need to divide both sides by 2.4. In other words, some number x multiplied by 2.4 gives me 4.8. I need to divide 4.8 by 2.4 to get what that number is. X is equal to, and I'll type that in, so 4.8 divided by 2.4. Oh, sorry, which gives me an answer of 2 centimeters. Okay, so that's 2 centimeters. I can write that into my diagram. Now, like before, I need to make sure I've actually answered the question. It says find the perimeter of the rectangle. I'm going to move over to the right-hand side to get a bit more space. The perimeter of a rectangle is just the distance around the outside. So it would be that side, add that side, and then these two sides added together as well. Now, if you notice, this side's the same as this one. So I can say the perimeter is equal to 2 lots of the 2.4. I've got 2 of those sides. And then I'm going to have to add on 2 lots of the width, which is x. So add on 2 lots of 2. And using my calculator to do that, so 2 multiplied by 2.4, I can type the whole thing into my calculator, add on 2 multiplied by 2, which gives me an answer of 8.8. Perimeter, of course, is a distance because it's the distance around the outside of the shape, so the units for that are centimeters. And that's my answer. Pause the video and give this question a go, and we'll run through the answer in a second. Okay, let's go through it. The triangle and the rectangle have the same perimeter, so not the same area, but the same perimeter this time. Find the area of the rectangle. Okay, let's work out the perimeter of the triangle. This is an isosceles triangle. That's what this little symbol means. It means this side is equal to this side, and actually this angle and this angle would be the same as well. So this side is 4.7 centimeters. The perimeter of the triangle is the sum of all those sides. So let's go ahead and do that. We'll say the perimeter of the triangle. Let's write it like that for short. So the perimeter and then a little triangle beneath is 4.7, add 4.7, add 6. And let's work out what that is using our calculator. So 4.7, add 4.7, add 6. That gives me an answer of 15.4 centimeters, like that. And the triangle and the rectangle have the same perimeter. In other words, if I added up all the sides of the rectangle, the answer to that is the same as the answer to the triangle's perimeter. Of course, this side of the rectangle would be x centimeters, and this side would be 3.5 centimeters. Let's go ahead and look at the perimeter of the rectangle. So to do that, I'd have to do x add x, which I could write as 2x, but I'll just write it like this, x add x for now, and then 3.5 add 3.5. I can collect together my x terms, so x add x is 2x, and 3.5 add 3.5 is 7, so that's the perimeter of the rectangle. It's 2x add 7. Because the triangle and the rectangle have the same perimeter, I can let this perimeter, the 2x add 7, or the expression for it, be equal to the 15.4 centimeters. So let's do that. The perimeter of the triangle is equal to the perimeter of the rectangle. Therefore, the 15.4 centimeters is equal to the 2x add 7. I'm going to subtract 7 from both sides to get 2x on its own. So subtract 7. I'll do 15.4 subtract 7. That gives me 8.4. So 8.4 is equal to 2x. And then I would need to divide by 2. So I'm kind of running out of room. Let's do that over here. So 2x is equal to 8.4. So x is equal to 8.4 divided by 2. So x is equal to 8.4 divided by 2, which is going to be 4.2, but we have our calculator to do that. 4.2 centimeters. Okay, let's pop that back onto our diagram. So this is going to be 4.2 centimeters, and this would be as well. So unfortunately, my camera that was recording my calculator just died. But the next step would be to work out the area of the rectangle. So the area of the rectangle is going to be the width, which is the 3.5, multiplied by the length, which is the 4.2. And I'm sure you can type that in your calculator without me showing you how to do that. But I'm going to go ahead and do that. 3.5 multiplied by 4.2 to give you an answer of 14.7. It's area, so it's centimeters squared. For the next question, we're not able to use our calculator. It says calculate 11 multiplied by 1.5, subtract 1.5 multiplied by 7. Now, there is actually a clever way to do this. I don't have to go ahead and work out manually what 11 multiplied by 1.5 is and do the same for this. There's actually a clever way to do this. I'm doing 11 multiplied by 1.5, and then I'm taking away 7 lots of 1.5. I can rewrite this calculation as follows. 11 multiplied by 1.5, subtract 7 lots of 1.5. Multiplication is commutative. That means I can actually change the order and it gives me the same calculation. In other words, 2 multiplied by 3 is the same thing as 3 multiplied by 2. So that's what I've used there to do this. And then what I can use is what's called the distributive property. If I have 11 lots of 1.5 and I'm taking away 7 lots of 1.5, that's going to give me 4 lots of 1.5. We could show that like this. We could do 11 subtract 7 and then multiply that by 1.5. And it's going to give me a quicker way to do it. 11 subtract 7 is 4. So I've actually got 4 lots of 1.5 when all is said and done. And then I can do this calculation a lot easier. Now I happen to know that 2 multiplied by 1.5 is 3. Therefore 4 multiplied by 1.5 is going to be 6. So that's my answer. Pause the video and give this question a go and we'll look at the answer in just a second. Okay, so we've got 2.4 multiplied by 15 and then we're taking away 2.4 multiplied by 11. Now, just for the sake of helping us to understand it a little bit better, I'm actually going to rewrite this as 15 lots of 2.4, take away 11 lots of 2.4. It's probably easier to think of 15 lots of 2.4 than it is to think of 2.4 lots of 15. And if you can imagine you've got 15 lots of 2.4 and you're taking away 11 lots of 2.4, well, that would be the same as doing 15 take away 11. In other words, it's going to give us 4, like before. And then multiplying that by 2.4. 15 subtract 11 is 4, and then I'm multiplying that by 2.4. Let's use something similar to what we did before. If I know that 2 multiplied by 2.4 is 4.8, so just multiplied each of those by 2, then I can work out what 4 lots of 2.4 is going to be. Well, it's just going to be double this. So I need to do 4.8 multiplied by 2. 2 multiplied by 8 is 16, exchange for the 1. 2 multiplied by 4 is 8, add on the 1 to give me 9. So this is 9.6. And that's my answer to this calculation. So hopefully you got that. The last thing we're going to look at is just a clever way to do this calculation. So here we have calculate 14 multiplied by 3.5. So I want to make this calculation as easy as possible because I don't have a calculator. I'm going to rewrite the 3.5 as 7 multiplied by a half. And that's true because 3.5 is a half of 7. And then I'm going to rewrite my calculation. So instead of doing 14 multiplied by 3.5, I'm going to do 14 multiplied by 7 multiplied by a half. And again, because I can change the order in which I multiply these numbers together, I can rewrite this as 14 multiplied by a half multiplied by 7. I can do a half of 14 relatively easily to give me 7. So I just did that part to give me 7. And then multiply that by 7. 7 multiplied by 7 is 49. So it's a much easier way to do that calculation. Another way we could do that quite easily is we could think of it as 14 multiplied by 3, add on 14 multiplied by a half, or 0.5. Because I've got 3.5 lots of 14, so I want to do 3 of them and then add on a half of 14, which is what this calculation shows. 3 multiplied by 14 is like doing 3 multiplied by 10 to give me 30, and then adding on 3 multiplied by 4, which is 12, and then I need to add on a half of 14, which is 7. I'll do my 30, add my 12 to give me 42, add on my 7, and again I get back to 49. So that's another clever way to do that calculation. Give this one a go and then we'll have a look at your answer. So we've got 18 multiplied by 2.5. I'm going to rewrite 2.5 as 5 multiplied by a half, like that. And then I'll rewrite this calculation as 18 multiplied by a half multiplied by 5, because this is equivalent to what we had before. 18 multiplied by half is nice and easy. That gives me 9, and then multiply that by 5. 9 multiplied by 5 is 45. The other way to do it is to think of it as 18 multiplied by 2, and then adding on a half of 18, like this. 18 multiplied by 2 is 36, and then 18 multiplied by a half is 9. If I add these together, it gives me 45. So you can do it that way as well. If you're using our lesson booklets, now complete exercises 1 and 2. Thank you for watching this video.